Start.
Recording in progress.
Hey everyone, it's your holiday edition. I don't even know what holiday it is. What day is it? President's Day? Martin Luther King Day? Hell if I know. It's a day off. We got a day off and here we are doing some work. Why? Because we got a test coming up soon and I want to make sure you guys have a good bit of review going on. So we're going to go over 2 assignments. This is like a street version of craps, not the casino version, which would take more time. And then we're going to look at infinite series and how they calculate it. Something you'll see a lot of in calculus 2 near the end, but we're going to look over how to code some of it up. So let's start with this one. Then review craps. It says create a dice rolling game, roll 2 dice. We want only one separate function that returns a random number. So only one function. And then code within the run again routine. So let's start up Microsoft Visual Studios. Do not recover. And we'll create a new project. And we will start with the run again one, although it sounds like I can't use it since it says only have one function. But I can copy and put in code as we're going and work from that. So we got a source file already with that one. That's pretty good. We got a program template. I'm going to change my name right now. A lot of you are not putting your name. Date, what is today? 2/21/2022. And the lab name. This is review for test craps edition. And it said only one function. So I'm going to actually try to see. Let's see what we can pull up here and put in the main. I'm going to take this char user response, put it up here somewhere in the main. And then we'll pull this into the main. All of this into the main. Probably at the end of the do loop. Don't need the char user, we already did that. And then instead of doing while run again, we can actually just do the while the user response. Pull that out. Put that there. Get rid of that. And I'm just going to make sure I did that correctly. So I'm going to run it as it is without doing anything in the craps. I would like to run again. Yes, I'd like to run again. No, I wouldn't. Okay, good. That worked correctly. I don't need this anymore. So that's a way of taking that, putting that in there. We won't have that. And now, what was our assignment? Code only one separate function, int roll die void. So int roll die void. And we're supposed to return a random number between 1 and 6. So I'll put that again down here. And let's see, we like make an integer int die roll. Well, to get 1 to 6, we needed that rand function, right? Do modulo 6. But that's going to give us 0 to 5, so we need to add a 1 to it. And what do we do when we have rand? Anyone know what we should do when we have a rand? Something's missing here. Oh, I see stuff in chat. See the random numbers. That's exactly right. Thanks, Ethan. So, shit. How do I do that? Include what? C time, I think? That sounds about right. Oh, that's one of the things. Yay for auto population. And we need to seed it, so srand. How do I do this? Times 0. That sounds about right. Let's see if my die roll works. C out, die roll. Takes in a void. So we'll do that. Oh, nope, not die roll. Roll die. See how roll die. Let's see if that works. Let's see if I made our die function work right. I got a 1, and I'll say, oh yeah, it did seed it. Okay. Okay, so die roll's working. What else did we need to do here? Okay, use the function in the main to generate the output. We're rolling 2 dice and adding them up. Okay, so back to our code. So I'll comment it or document it a little bit. Seeding the random number generator. And we don't want to see out the die roll. We actually want to use it, right? So let's make 2 new integers, die 1 and die 2. And we'll let die 1 equal roll die. We'll let die 2 equal roll die. And total, or sum, I guess I need an integer for sum, right? Sum of dice. Sum dice equals die 1 and die 2. Let's just see if that part works correctly. How did we have the code? What was the recommended? Rolled. There we go. Okay. Rolled the numbers. Rolled. We want to say die 1. And then die 2. Throwing an end line. And notice the spaces here should make it look like the spaces in the text. A couple of you are not doing that in your code. Hopefully the later assignments have a little bit better. It does make it easier to read. It looks better. Let's see. And we have to see out the total, right? Just the total. Okay, see out. And I'll put a space there so it looks good. And this is some dice. All right, let's see if that worked. Snake eyes right out the gate. Okay, it's working. I wish I had some more spacing in here. But I am getting what I like. Okay, so that's looking good. Maybe we'll put another space in there. Maybe I'll put a space in at the beginning. And let me document my code while I'm going. So this section here, we do some function calls to roll die to get 2 dice values, and then add them up. And that will be this little block right here. Now I'll do some documenting. Here we do a cout so that the user knows what we got. And then this section is, this is our run again without the function. And what I'm doing here, it's called documenting. It makes it easier to read or look for errors. If you know what a specific section of the code is supposed to do and it's not working, it's easier to find it. I strongly recommend doing this during the test. If it doesn't run and I don't know what you're doing and I can't follow it, it's really easy to give a 0. If I can follow what you're doing and realize you just missed a parentheses or something like that, I can give partial credit. I'll feel better about it. What else have I done here? We did some function calls to roll die. I did name my, I'll put that up here, up top. Here, I named my variables so that I know what they are later on. Really helpful. Some people are using A, B, and C religiously, or X, Y, and Z religiously. One of you, maybe 2 of you, has been having fun with delta, epsilon, and gamma in the functions, which is fun until I can't figure out what's going on, and then it's like I don't want to go through the effort of figuring out what delta, epsilon, and gamma, or A, B, and C is supposed to be. So I just say, I don't know what you're doing, and send the assignment back. But it's a test, so there's no kicking it back. You gotta get it right on the first try. So maybe name your variables so that it's easier to follow, and that it might be easier for you to do the code right. Let's see. Okay. So what else do we got here? What else was asked? Add commentary. If the total equals, I should have done this in the first place. Copy this over and let's put it in our code. I'll do a little comment section. Ooh, ugly. What happened? Oh, it just went off the screen. There we go. If total equals 7 or 11, output you win. If the sum is 2, 3, or 12, output craps you lose. So let me copy that line down here where I'm going to be doing it. It needs to be after we rolled the output, right? That makes sense for where it goes. In fact, that makes actually pretty good documentation for what I'm doing. It will make sense. So I don't have total, I have some dice. So I need to do if some dice equals 7 or 11. What's wrong with that? Is there anything wrong with the way I entered that?
You have to write some dice equals again.
I do, right? This is doing 2 separate things, and it's checking the condition 11, not to see if it's equal to 11. Nailed it. Good job. That should work. And so what were we saying? We're going to output see out, you win. And then it said otherwise, if the sum is 2, 3, or 12. So I can do an else if sum dice equals 2 or sum dice equals 3 or sum dice equals 12. Here we'll enter you lose, craps you lose, which means we got to do a C out. Let's just be smart about it. Copy and paste it. Oop, look at that. That was a comma. And then maybe we should do, it didn't say it, but it doesn't say win or lose, so maybe we should throw that in. Let's do an else. It doesn't say it, but the game, there's other outcomes, right? Else, see out, you neither won nor lost. Boring. How's that looking? Let's see. Let's give it a try. Okay, we got an 8. I neither won nor lost. Boring. Yes, let's do it again. Okay, we're aiming to see if we ever win. 6. It's kind of fun to see the results on the craps table. In fact, I'll pop up the screen real quick to show you the outcomes of dice. A 5, 5, and keep getting 5s. A 4, 8, 11. We won. I want to see if we lose ever. Trying to, there we go. There we got a craps you lose. So I'll say no. So like, let's just look at dice rolls. Roll table. So you can see along the diagonals, the numbers are constant. So like there's 1, 2, 3, 4, 5, 6 7s, and then 2 11s. There's 8 ways to win. The ways to lose are 2, 3, 3, or 12. There's only 4 ways to lose. And then the rest of them are just non-outcomes. And that's one way to play craps, even in a casino. Oftentimes, it's kind of hard. The other way you do, oops, let's reopen that. You can also bet on, you roll the dice once, it sets a value to hit. And then if you're not betting on the 7 or 11, you're betting the other value will come before the 7 or 11. Like if you bet on 6s, there's 5 6s here. So it happens less often than the 7s. It's a little harder to win that. Let's go back to our thing here. Did we miss anything? Use the function in the main to generate the output. See if I can make that. Maybe not. I don't need to make it harder. Like, well, I'm going to, just for fun. Oh, no, I can't. Because I need the roll dice first. No, I can do it that way. Coming out that. And here I can say you rolled die 1 equals roll die, and put this here, and die 2 equals roll die, and then put this sum dice. Do I even need that? I could just put this right here. Put this right here, and now I don't have those 3 lines of code are unnecessary. Does that work correctly, though? Why does it not like it? Nope. So maybe this was a bad idea. There's a way to make that work, but it's unnecessary. There we go. All right, so we have the win, the lose. We have our run again in it. I think we've met the requirements of it. Everything's looking good. Try to make it a little cleaner, easier for the teacher to read. Let's see. I don't need these up here anymore. We'll leave the documenting part in there. Maybe I'll put an extra space here because it kind of points out what's going on there. Put an extra space there, and then that's looking good. Everything is looking good. Some of you like doing this to make the function implementation pop. I like it. I showed it in at least one of the videos. It kind of makes it stand out when you're scrolling through the line of code. Some have even done it where it's like this. I guess I should do that. This is handy. It's easy to read when you're scrolling. You get to a big wall of asterisks, and you know this is where the function implementations are starting. Mia does this. Mia likes doing this. She's very good with asterisks, aren't you, Mia? She is the asterisk queen. I think we got a lot of people here now. Nice. All right, so I think we met the requirements of that one. And if we wanted to make this more fun, we could put some wagering in there, but that's not really necessary. Notice it did say, be sure to include only the lines of code you wish to repeat within the game loop. And that's why the variable declarations are outside of it. It's very important that you do that. I don't want to put int die1 in here. Or, like if I do this, it's trying to redeclare die1 as a variable every single time we do the game loop, which is bad. So we don't want to do that. That's the same for for loops, while loops, all that good stuff. I am missing a curly brace. Make sure it works, and then we'll close that one out and go look at the next one. Is there any questions on this? That's a lot of 4s and 6s. 1, 2, 3, 4 out of 6 rolls had a 4 and a 6 in that exact order. How variable are we? I see nothing in chat, so that'll be it for that one. And we'll go look at our next one, the infinite series. So calculate the value of pi from the infinite series. Let's start up a new program. I don't really need to run again here. Review infinite series. You guys will do series later on in Calculus 2 if you're in Calculus 2 right now, or if you've already taken it. And this one I'm starting from scratch, so I got to add a new item. And first things first, I always put my name, El Jefe. Today's date, 2/21/2022. And this is our review using infinite series. Well, it's going to be semi-infinite because we're making a computer program, right? What do we need to include? IO something, right? IO stream, sound about right? We want using namespace std. And then we'll just go start our int main void. Now, since I have integer as the return on my main, you really want a return there of a value. You really should put it in there. Don't assume every IDE is going to do that for you. That's very important. And I'm going to make notes of it here. Don't assume that every IDE does stuff the same. And so put the return for int main void. Also, be sure to include libraries that are necessary. Some programs, some IDEs will do math operations without including the math library, but you might need to include CMath. We might even need to do it in this one, I don't know. Some of them automatically include strings, but not everything does, so you might need to include the string library. Or other libraries, stuff like that. All right, so let's go look at what this one was asking us. Let's just copy and paste it. That way I don't have to keep scrolling back. I'll put it down here after the main in a comment block. Oop. So we're going to calculate the value of pi from an infinite series. Pi equals 4 minus 4/3 plus 4/5 minus 4/7. Let's take a look at what's going on. I'm going to pull up my tablet. And let's see. Share screen, generate a code. And yes, I would like to share screen. So we're looking at our infinite series project. And it said pi equals 4 minus, I think I have these signs right, plus 4/5 minus 4/7 plus 4/9 minus 4/11. Let's make sure I have that right. Let's just go look at that real quick. The 4/3 and the 4/7 are negative. Yeah, I got the signs right. Okay. And then it's got dot, dot, dot. All right, so how could we do this? We don't know how long we're going to, or maybe we know how long we're going to go. Maybe we'll say we want to do it to like 100 places. Let's, not 100 decimal places, but let's just do 100 steps. Let's do 100 of these. So, like if we're doing something like this, it sounds like a loop might be pretty good. Like maybe we had a for loop. So let's think about maybe doing a for loop. And so we'll need an integer. Maybe we should start, we'll use an integer, we'll use an index of I. And let's just call this first one the 1. So I equals 1. That'll be where we start. And our first value is 4. And then we have I equals 2. And we've got negative 4/3. And we've got I equals 3. Will be the next one, which is the plus 4/5. And I'm writing these out so we can try to look for a pattern. Because for our for loop to work, we're really going to need a pattern going on here. I equals 5. I've got plus 4/9. And I equals 6. I've got minus 4/11. Oh, well, I didn't want that in blue. I'm going to change that. And I see something else that I probably should do. And these denominators are all odd integers. If I put this over 1, 4/1 is still 4. And this is still a plus, really, if I want to think of it that way. So if I wanted to make the denominator related to I, that looks pretty important, right? Because that's what's changing. What's changing is the denominator and the sign. So we need to address both of those in our steps. So let's just try to figure out what a general formula might be. If I did 4 over I would have 4/1, 4/2, 4/3, 4/4. That's not really what we're looking for. How would 4/2I look? Then I would have 4/2, 4/4. I'm not getting odd numbers that way. If I add 1 to it, what happens if I add 1? My denominators change. Adding 1 might be wrong. I'm going to erase that because it looks like trash. 2I plus 1. Well, I equals 1 is going to give me 4/2 plus 1 is 3. That's not good. That went the wrong way. I equals 2 would be 4/4 plus 1 is 5. Now, this could work if I started at I equals 0. Because I equals 0, the first step would be 4/1. I don't want to do that, though. I want to start with I equals 1, because that makes, when I'm counting how many times I do something, starting at 1 makes sense. Doing it 10 times, I should have a counter of 10 when I do it. That's how my mind works. Starting at 0, then it stops at 10 when I get to 9, and that just is confusing. So let's edit this. Maybe let's try -1. Let's see what happens. If I do I equals 1, I've got 4/2 minus 1 would be 1. And I equals 2, 4 over 2 times 2 is 4 minus 1. I'd get 4/3. That's looking promising. I equals 3. 4 over 2 times 3 minus 1 is 4/5. I'm getting the right values now, right? Except for the sign. So it looks like 4 over 2i minus 1 is where we want to go. The question is, how can we do this sign thing? There's a couple ways of doing it. One way of doing it would be doing powers of -1. So I could multiply this by -1 to some power. What happens if I use I? When I do I equals 0 or I equals 1, this would start me off as being -1. I would have -4. I don't like that. Maybe let's try I plus 1. If I do I plus 1, -1 to the 1 plus 1 is 2, and I get +1. And that would work here. That would be positive there. That's correct. Let's see. I equals 2. I get -1 to the 2 plus 1 is -1 to the third power, which is -1. And multiplying that would make this negative. That's matching up. Let's just make sure I equals 3 works. If I do -1 to the I plus 1 is 3 plus 1. I get -1 to the 4. And that's +1. And we'd have a positive there. So this is looking like what we're doing. So let me come type that over here before I get rid of it. Let's see. Let's put this in our code as a comment block. I had 4 divided by 2i minus 1. And then I multiplied by -1 to the I plus 1. Is that right? 4 over 2i minus 1, and then I've got times -1 to the I plus 1. That's looking pretty solid right there. So let's try setting that up. It says make a double calculate pi. Function. Maybe let's see. Let's just make sure this works. How would I code this up? For int I equals 1, I less than, let's say 100, I plus plus. Let's just see out what the value would be. I don't want to go that high. I'm only going to go up to like 5 because I can do that on a calculator real quick if I wanted to. Nope. I need to do the calculation. I need 4 divided by, I need 2, and I can't do 2i, I need to do 2 times I, minus 1. And then I can't use -1 like that, can I? It does look like I do need to include C math for the powers. For the alternating series part. Signs of the series. So for the alternating signs of the series, we'll put that in. Now, how does that work? It's pow. And you do the base is first. And then the comma, and then the power. We wanted, I don't want capital I. I want I plus 1. And I'll do an end line. I just want to see if this works. What is the flashing light bulb? Oh. I'm going to make this 4.0. I think I'm going to have integer division there. I think it's going to fuck it up. But if I make 4.0, now I have a double there. Ooh, that's me thinking ahead. Look at that. Let's see how it would have worked without it. 4, -1, 0, -0. That's terrible. Yeah, I think we're getting integer division there. So let's see what happens if we add the 4.0. So we had 4 and then minus 4/3. That's -1.33 is -4/3. Plus 4/5 is 0.8. 4/7. Let's see what 4/7 is. 4 divided by 7 is 0.57142857. Looks good. Looks like we're coming up with the right values. So now that we have that, now I know the code works. We'll leave that there. This was our handwritten attempt to figure out the code. See the video. All right, so it says calculate the value of pi from the infinite series. This should be done in a regular function which takes in as an integer parameter the number of terms for the summation. The results should be returned. The function prototype might look like the following. Double calculate pi integer num terms. Okay, that sounds like a good one to use. Let's use that. So prototypes, not integer though, huh? Int. Prototypes of functions go before the main. There's no code here. This is like the chapter title in the front of the book. Okay. Some people were having a couple issues like that. They'd have everything up top, or they would have like calculate pi. They'd have it down, have it listed both, have the full code in both spots, but then change the one down here. They would put calculate pi implementation. And that's not how it works. The name has got to be the same in both places. So I want the name of the prototype to match this. So I'll make that little comment here. Prototype name above needs to match exactly. And we don't have the integer. We just have int. And so if we're calculating pi, it sounds like we're going to need this little bit of code in there. And we want it needs to return the sum. So let's just say return sum pi, which means I need to make a variable for sum pi. Let's call it a double. And that means I'll start some pi out at 0. And we want it to do, let's see, this should be done. It takes in an integer parameter, which is the number of terms. That should be the size in my loop, right? I should do this should be my num terms right here. And now I don't want to see out what it is, because we already tested that. So I'll comment that out, but we're going to borrow from it. We want sum pi to be equal to, we want it to keep adding, so we're going to say sum pi plus that value right there. Another way of writing that is sum pi, you do plus equals, and then just do the calculation. In fact, I'm going to leave that one. I'll comment out the other one. We'll get rid of the C outline. And let's just see how this works. Let's try it. I need to call it. So we never really want to, unless it says to do so, never put your couts in the function. Now the reason why is if you want to reuse this for other stuff later on, you don't want the couts in the, you don't want to necessarily see it out later or print to the screen later. Like if you're working with triangles, you may just want the area for some other use, especially in like calculus. If you're doing like you're approximating an integral using C++ like we did in that last week, and one of the things is a triangle, and you're just doing triangle slices. We don't want to print that triangle area every time to the screen. So you want to do the cout in the main, and the way we can do this is you reference the calculate pi up there. So I'm going to copy this just to make sure I don't fuck up the name. And I'll do cout after, well, num terms seems like a good thing to use. The value of pi is, and here's where I'll put, that just done fucked it up. We'll put calculate pi right there. So that's me doing a function call in it. And I don't have a num terms in here, so it looks like I need to add num terms, right? And it says it's an integer, so we need to make it an integer. So if it asks for it, the assignment says integer, use integer. If it says use double, use double. And so like I'll comment this out. We don't need this right now. Let's just start with 10. Let's see what happened. Oop. That's what's missing, or that's what's wrong. There we go. So we're calculating pi with num terms. We've declared it up here. This is just seeing if it works for small number. Let's see what we get. Well, that doesn't look like pi, does it? What happens if we tell it to, let's go to like 20 terms. And let's tell it to see out the value each step of the way. I'm going to comment this out later, but we're going to just do it right now. This is for, this line will be commented out. It's used to see how the program is working. So each step of the way, it's going to show me what the value is. Let's go to 20 terms and see what we get. So it started at 4, then it's down to this. It's kind of bouncing around below it and above it, right? 2.97 is below it. 3.28 is above it. And that makes sense because we've got that minus sign in there. That plus and the minus. So one time it's adding it, the next time it's subtracting it. It looks like 20 terms isn't enough. What about like 100 terms? Even after 100 terms, it's not working very well. But I don't really need all this code. I do see it's ricocheting back and forth around it. I know that's working. So I'm going to turn that off. Let's see. Are there more instructions? In the main, print a table that shows the value of pi after each 10 terms of the series. Well, it looks like my little rule of thumb of don't put your C out in the code, we might have to break it. We might actually have to do the C out in the function. Because we don't want to send in 10 and then like it's going to throw it off. So maybe we do in this one case. When the code required or the assignment requires us print out more than one time at different stages in the function, we do need the C out in here. So I'm going to do that here. Now we had the C out some pi, but we were doing it every time. We don't want to do it every time. It says after each 10 terms. Any ideas how I can make that happen here? If only we had a way to count how many terms we've done so far. Any ideas? Well, if we just did it like this, let's see what happens if we do it like this. The term number 4 is the first term. 2.667 is after 2 terms. 3.4667 is after 3 terms. 2.89524 is after 4 terms. The number of terms seems to match up with what stage we are in the for loop, right? It's actually matching up with our index I. So, like, how do we check? So index I is matching up with the number of terms. How can I only check multiples of 10? Well, I could just keep subtracting 10 and then seeing if the result is 0, right? So like if I equal 20, 20 minus 10 equals 10. And then 10 minus 10 equals 0. And a result of 0 means this is a multiple of 20, or a multiple of 10. Because like if I had I equals 19, or I equals, 19. 19 minus 10 is 9. And if I try to do 9 minus 10, I get a negative number. So we want repeated subtraction. We want repeated subtraction to yield a remainder of 0. What operation in mathematics is repeated subtraction? Is anyone here, or there's still 6 participants? Anybody even listening, or did everyone just walk away? Ooh, we got chat. Okay, me is listening. Any ideas on what repeated subtraction is? This is a common operation, actually. What would repeated addition be? Like if I keep adding 3, 3, 6, 9, 12. The dash dash, like subtraction, I could do minus. Doing dash dash means -1. Like, are you saying I minus minus?
Are you trying to say division?
Yes. Repeated subtraction is division. And we want the remainder. Which operation in C++ gives us the remainder, not just the amount when you do division?
The modulus operator?
The modulus operator. Yes. Excellent. Yay. So we're kind of looking for like I mod 10. If I do I mod 10 and I get a 0, then I am on a multiple of 10. So we'll do that. If I mod 10 equals 0, and then we'll do this. I don't even need the bracket because we're only doing this right here. Oh, it did say to make it look pretty. Show calculate pi. Okay, so let's make this look a little bit prettier. Calculate pi parentheses, and then I wanted to show my value I, and then I want the end of the parentheses, and then I want it equals, and then that. Let's try that. So this part's giving me the calculate pi with the number in parentheses. Look at that. So maybe I should just do this up above in the main. I'll comment that line out. We'll put this here. And then just do, this should be num terms at this point outside the main. And this will be the value of the calculate pi. So let's comment out that line. I want to make sure that worked before I do anything more. And it did. All right, so let's see. What were my instructions? Pi, this should be done in a regular function, which we have. We takes in an integer parameter. We did that. In the main, print a table that shows, ooh. In the main, print a table. I don't know that doing it in the main works very well. That doesn't seem like a very good question. We do have a looping structure, it says. You should see it converges to its actual value as the number of terms increase. How high do we gotta make this? What if we do like 1,000 terms? I'm going to make this so it says imod 100 for now, just because I don't want to see all those lines of code. Let's see if 1,000 gets us there. Closer, but it's 14159. What about like 2,000? Let's go 5,000. Still not there yet, right? Looks like this takes a lot of terms. We still haven't converged to 4 decimal places yet. So maybe we'll do this. Add another 0 up here. Let's see if 10,000 terms. Actually, that's 100,000 right there. 100,000 get pretty close, right? 3.14158. Maybe 200,000. Oh, we got there. We got to right here, 131,000. We got to 5 decimal places. Interesting. So what are other ways we could do this? Now, I did the alternating series using powers, doing the minus and plus. Let's look at another way of doing that. Get rid of that. Because teacher doesn't need to see all that crap. I think we met the assignment. We did see it converge. We did the looping, and we printed everything to the screen. So let's get rid of all the stuff that doesn't work anymore. Actually, let me put the comments back in case I post this. There we go. If I save the code and post it in an announcement. All right, so another way to do this alternating series where it's plus or minus is we could create a Boolean. And we'll call this pi sine. Wait, maybe not a Boolean. Let's just make a counter. Or a multiple. Int sign changer. And we'll just start it off as 1. So I'm going to copy this, and we're going to get rid of the power part. Because there's more than one way to get that alternating sign. If I make it multiply by sign changer, right now sign changer would make it positive every step of the way. And we don't want that. We want the first step to be positive, and it is with a 1. And I could go in here and say sign changer equals sign changer times -1. And then after I equals 1, the next loop sign changer will be -1. And after the next loop after that, sign changer should be -2. Let's go back to just doing 10 lines real quick. And we'll just say I equals 1 for this right now. Let's see if the sign changer process works. If this is a simple solution to getting that alternating series without powers. And this looked like just like it did before. 4, 2.66. It looks like the values are similar. Maybe I should see out the value, or see out what that value is each time. We'll get rid of that comment line in a second. I made it look sloppy. Let's comment that out real quick and do that. Make it back to 10. That'll fix it. That looks like garbage. Let's put an end line in there. Can't read that. There, that's alternating. It's still working. So negative 4/3 is negative 1.33. Positive 4/5 would be 0.8. It looks like that works correctly. So that's another way to solve this problem. And this approach, let's see, we don't want to see this out every time. But the sign changer approach doesn't require the C math library. So I could get away with it that way. So we could do either one. What else could we do in this that makes it pretty? Got I equals mod 10. Maybe we could ask the user how many steps they want to use. Let's do a cout. Well, I didn't even say what the program does, right? This program calculates pi, an infinite series. I'm going to do an end line because when I'm trying to read this and the code is 15 lines long, it's hard to read. Like it wraps along and it'll go too far on the screen, but this way I can make sure it doesn't. This program calculates pi as an infinite series. We need a number for how many terms to use. Please help, or please provide that. Please provide a number. And then I can see in that, right? See in num terms. And if I do that, now it should, we can run it. And let's just say, well, I knew 131,000 got us there. And it's printing out the screen every 10, which is what the program asked. Maybe we could do fixed or set the precision. So this is a handy way of getting the precision to work. That floor scale thing doesn't always work. A couple of you have been using. Let's see. 14159 is 5 places. Let's just do it to 8 places. Let's make it show a little bit more. Oops. And this is getting a little long, right? So maybe rather than doing num terms equals, or this value that we sent in here, how often we see out, maybe we could add to this. Let's make it better. Let's add another one. Let's call this print frequency. We'll default this to 10. And now let's just ask them how often. This takes a lot of numbers. How often should I show it to the screen? Or after how many after how many steps should I show the current end line there result to the screen? I'll do an end line here. I'll do a CN of the print frequency. Now, if we did the print frequency like this, we need to be able to pass it in to calculate pi. So this is a little different than what the assignment was asking, but this is just making it better. Let's pass that in. We'll call that print terms. And I'll come down here and add that in here. And now where that's used is it's used in this imod. We're going to say imod print terms. And if I did it correctly, now I can say don't do it every 10. Do it every, 1,000. Something's off. What's off? Oh, I changed this, but I didn't change this. I need to add print terms or print frequency right here. That's what's off. Let's give that a try. So we'll tell it to go to 200,000 places, but I don't want you to do it every 10. I want you to do it every 1,000. Better yet, 10,000. Oh, that was quick. You see how quick that went? Doing it 10 at a time took a long time. Doing it this way took less. It works well. I just don't like the way it appears. I'm going to add some spacing in there. So one way to add some spacing is after we do this program calculate this line right here, that's like really the title. And then maybe we should add some spacing in after that, after we ask how many terms and then how much the print frequency is. So I'm going to see out another end line right here just to create a gap. And now we can have fun. Let's just... Ooh, that's pretty good. Goes pretty quick. Maybe the only other thing we could do to make it really, user-friendly might be ask them how many decimal places do we want to show. How many decimal places should we show? And I guess I need to come up with a value for it here. Desk places. And we'll make another integer for that. And I know this isn't going to work, but I want to show what happens when I do it this way. So we're going to do 500,000. I'm going to tell it to go, oh, decimal places, I want 3. And we'll tell it to do it every 10,000 times. And it doesn't show 3 decimal places. And the reason why is sometimes we do stuff in the code where when we enter more stuff, we've got it in the wrong spot. I haven't actually referenced the decimal places here anywhere. I want it in the set precision, which means I should probably change the set precision to show up after that line. And then we'll set precision here to decimal places. And now that should work. So I'm going to just tell it 1,000, and we're going to do every 10 terms. But I only want to see it to 3.14. I want to see 3.14. How long does it take to get there? Not too long. Got to 3.14 after 160. Interesting. Something else you can do. This is not necessarily a review for the test, but it might help. Yeah, well, actually it is. It's not what the assignment asked. What if we don't know how many terms? Like we don't want to say. We know what pi already is, and we want to see how many decimal places to go to. So let's just go look up decimal places of pi real quick. I don't want that. I don't know what that is. Or pi. Let's just do pi. Let's use that value right there. So another fancy way you can do this is, let's see. We've got this for loop right here. I'm gonna wait. Let me paste pi real quick, and I'm gonna comment this loop out real quick. Actually, I'll leave it in. I'm gonna make a new function. Double pi by comparison. I'm going to call it that. I'm going to tell it to take in the number of decimal places. Nope, that's not going to work. I'm just going to say void. So I'm going to make a new function down here. I'm going to do everything we had here. I'm going to have double sum pi. We'll do the int sign changer. I want these 2 lines of code there. But I'm gonna make my index out here, int I equals 1. And now what I'm going to do here is I'm going to do a while rather than a for loop. While sum pi minus this value and maybe I need the absolute value of it. So I definitely want the absolute value of it. Let's say times I think absolute value is a it is. ABS is a CMath thing. Nope, it's in the standard library. I better include that then. While the absolute value of sum pi is greater than 0.0001. I am going to do this loop. And I need to increment I each time too. Because the for loop normally does the incrementing. Here, I need to increment it out it. But now I'm not going until a certain number of terms. I'm going until I'm finding out how many terms it takes to get there. So maybe I'll return I. If I return I, this returns how many terms it took to get that level of accuracy with pi. So this is another way, another thing that you can put in your toolbox. But remember, some pi, sometimes it was above 3.14, sometimes it is below 3.14. So I want to do absolute value there. And we'll leave it as greater than 0.0001. And now it's returning I. So up here, I'll change what my thing is doing here. Calculating pi by its margin of error took I want the return of it, pi by steps to get within 0.0001. I think that's the value I had down here. Let's see if that works. Oh, there we go. So I'm going to comment out the rest of this right now real quick. Let's just run that and see what it tells us. Took 100,001 steps to get within 0.01. So that's another way you can do projects like this. If you were trying to do it with your own stuff, you didn't want to set in a fixed number of terms. You could do where it's within a certain measured level of accuracy. And we will uncomment that. Bring that back up to the front. And so that we did the project and then we did a little bit more. So final thoughts, make sure, notice I got my name here, the date. I got the assignment date. Make sure that's there. Make sure you've got a return in your main. If this says int, you need a return. Unless the program specifically says like print out multiple times during a process, like the original function did doing this mod thing. You should do your couts in the main and do them as function calls like I did right here. So I did all the calculations, it returned a number, and I did the function call within my cout to find that number. Now I didn't need to. I could have set up a variable out here, int counter equals pi by comparison. And I could just do counter here. But I'm still doing a function call in the main to get that value. I'm actually going to move this up to the top to put it with the other variables. You kind of want to put all your variables and stuff at the top so they're easy to find. And you definitely want to do some documentation like we did in the last project. Here I got code all over the place showing different things we were doing. So, any questions? The test is going to have a multiple choice section, and then you're going to have 3 lab assignments. One of them covers, there's functions in several of them, or I think 2 of them have functions in them. One of them has you using the switch command. I have you, I'll tell you right now. One of the tests is one of the projects is you are going to write the lyrics using a for loop or whatever kind of loop you want to use and the switch command to do the 12 days of Christmas. This is not a song about, or this is not a statement of religion. I'm not religious. I'm actually atheist. Christmas is not a religious holiday for me. So this is not a religious like pressuring for you, but the song is a song and we're simulating how to use stuff like that thing. And then a couple of the others. The other 2 are not too bad. That one might be the longest one for you, simply because you haven't used switch a lot. But we have covered it, and it is kind of cool. Remember, for switch, so if I have an integer value equals like 3, and I could do switch value, and I believe it goes in braces. We do case 1, and I'll do case 2, and I'll do case 3, and then I'll do a default case. Oop. Okay, so if we're going in here, we can do stuff in here. This was case 1. And just to make this quicker, I'm doing this like this. And maybe we'll do the default case. I'm going to comment out this code real quick. We'll bring it back in a little bit. So if I run this like this, let's see, I'm going to do value 2. So we had switch, and it started at case 2, and it printed out everything below it. So that can be useful in writing the 12 days of Christmas. If you want stuff to repeat after it, you could have it below it and not have it that way. If you don't want it to repeat something, you need to include a break. So break will stop the switch cycle. Break stops the switch and doesn't show any subsequent cases. No break will show all the following cases that follow. That might be handy when you're doing your 12 days of Christmas. Just keep that in mind. The multiple choice thing, you'll have 2 hours. It's in Canvas. Once you start it, you'll have 2 hours to answer the question. Like one of the quizzes, basically. All the stuff should be in your reading material, or I've talked about it in class. Hopefully you know it, but there's nothing really stopping you from looking it up, other than sometimes it's hard to find the right wording for it when you look it up. But hopefully you know this material ahead of time. You've been doing quizzes like it throughout each module, so there's that. Any questions? Like, I've just been rambling for 2 hours basically. I'm gonna comment out that and bring back the other stuff.
I have a question, but it's not for this review.
Go for it, Kane. What's up?
For lab, I think it's like 4A and 4B. It asks like to code the flowchart, right? In that chart, are we supposed to make it into a function? Can I just put it all in the main function, or like the main thing?
That's a good question.
Whatever it's called.
Go look at it. Doesn't say anything about a function there on 4A. And neither does 4B. So no, it doesn't need to be a function.
Okay, cool.
Anybody else have any questions? Let's see. We got a question in chat. Nope, we don't have a question in chat. All right. The midterm is available, or not midterm, the first test. Midterm makes it sound like there's only one. The first test is available Wednesday morning, 12:01 a.m. I will be online from our normal hours on Wednesday from 4 to 6. In case anyone has any questions once the test starts. I think I'm in another meeting, but I'm going to have that meeting. I'll have 2 Zooms up. And so if you want to ask a question in chat, in the class chat on Zoom from 4 to 6 about the test, I'll be around to answer questions. You do not have to take the test during that time, but if you've looked at it or anything like that and have questions, that's a good time. Other than that, I'm done. This was it. Thanks for showing up on your holiday. I know you didn't need to be here, but hopefully you found this review helpful. And keep up the good work. I'm seeing improvement in the codes. Definitely seeing improvement. A lot of you got the memo that I don't want cheating or copying and pasting. I'm going to paste this on meeting on YouTube. Yeah. A lot of you got the memo about the cheating, and you just went and all right, he hasn't graded it yet. I'm going to change it. And I did not look at what you did before. I've been grading it. I'm on 3D now. It's taking longer than I thought, basically because I'm allowing students to resubmit, and I'm telling people generally what's wrong in their code, and it takes a while to type that up. And so regrading stuff that's already been submitted when they submit it again It's just taking time. I'm going to try to get as much done before this test even starts. I'm going to be working all day tomorrow on it too, and the rest of the evening. Hopefully we'll have a lot of it graded by then. I will see you guys on Wednesday, maybe. Otherwise, I will not say good luck on the test. Luck will not help you. Good practice, good study habits. That's what I'll wish you. And that'll be it.
Thanks, man. Have a good one.
You too. And the meeting.